This is a total production. Hello Chem Minions. In this video we're going to do two things. We're going to practice IUPAC naming for alkanes, and that's mostly on the chain side, but then also we're going to practice some Newman projections for two molecules looking down a specific bond. Alright, so the first six here, we need to give the IUPAC name for these guys. So what we want to start with is, since they're all chains, we want to find the longest continual chain. So it looks like something like 1, 2, 3, 4, 5. So what it looks like here is I've got a pentane chain, or a pentane parent, right? Because remember, this is going to require that you remember one carbon chains are methane. Alright, and as you go up in the number of carbons, it's methane, ethane, propane, butane, pentane, hexane, heptane, octane, and nonane, and decane. Alright, all the way up to 10. Alright, so 5 carbons, that's a pentane parent chain. And then we have these two 1-carbon branches coming off. So each one of these are called methyls. Alright, and so when there's 2 of them, we would say it's dimethyl. So I put the branches out in front of the parent. And then I need to find the locations or the numbers that I would assign to them. And so I want to start, if I start up here, the first branch I get is 1, 2. First branch at 2. But if I start down here, the first branch I get is 1, 2, 3. So I want to start with the branch occurring at the first branch occurring at the smallest number. So I'm going to label this as 2. 1, 2, 3, 4, 5. So it would be 2, 3 dimethyl. So 2, 3 dash dimethylpentane. Alright, yet again, let's start finding the longest continual chain. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It looks like from here to here is going to be my longest chain. So it's going to be 7 carbons long, which would make that a heptane, right? A heptane parent. And so all of this is a branch. This is a 3-carbon branch, but it's connected in the middle on that second carbon, right? So because it's connected in the middle of this branch, we would call this not butyl, but not propyl, but isopropyl. Alright, and to find the number, let's see, if we start at this end, it would be 1, 2, 3, 4. If we start at this end, it's 1, 2, 3, 4. So it doesn't really matter. So we'll just say 4 isopropyl heptane. Okay, so there's our name. Alright, looking at our next one, we need to find the longest continual chain. So looking at where these connect, that's a 3-carbon, that's a 2. So I'm betting I got to start here. 1, 2, 3, 4, 5, 6. That's not going to be good. 1, 2, 3, 4, 5, 6, 7, 8. It's going to have to go from dot to dot, right? That 8-carbon chain. We would call this a parent of octane. So that means I've got a branch here. That's a 2-carbon. A branch here and here. Each one of those are 1 carbons. So I've got an ethyl group and I've got 2 methyl groups, right? So when I go to number, I've got to get the branch. I got to start with the branch at the smallest location possible. So here it'd be 1, 2, 3, 4, versus here it's 1, 2, 3. So I'd actually have to start numbering here at the bottom. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I've got a 3, 4 dimethyl situation, and I've got a 5 ethyl. Now when I go to write these branches, I have to write them in alphabetical order. So here it would be E compared to M. Even though it's 2 methyls and I would say dimethyl, I compare the name of the branch, not the name and the prefix for the number of that types of branches, right? So I'm going to compare E and M. So I would have to name this 5 ethyl. If I can write my Y correctly. So 5 ethyl, and then 3, 4 dash dimethyl octane. Alright, throwing all that together. Alright, next up, finding my longest branch. looks like I'm going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it doesn't really matter. I'll just go from here to here. So now when I go and get my branching, right, I go 1, 2, 3. So I got my first branch at 3. If I go this way, 1, 2, 3, I get my first branch at 3. So I need to look at what these branches are called. This is called a methyl branch. This is called an ethyl branch. So when I have a situation here where the first, like looking at either end of the parent, if I get the same first branch location, in this case 3 for each one of them, I then need to follow the alphabetical order rule. So I would do E gets higher priority than M. So that means this would be 1, 2, 3, 4, 5, 6. So that it would be 3 ethyl, 4 methyl. Okay. Now remember, a 6-carbon chain, that means the parent is hexane. So that's my parent. Okay. So as we said, I would name this 3 ethyl, 4 methyl hexane. All right. So all of that. 3 methyl, 4 methyl hexane. All right. Next, looking at this middle one here on the bottom. The longest chain looks like it's going to be 1, 2, 3, 4, 5, 6. All right, so I got another hexane parent. And it looks like I've got 1, 2, 3, 4. Now I have 4 methyls. So if it's 2, we use di. If it's 3, we use tri. But if it's 4, we use tetra. So I have a tetramethyl thing going on here. Tetramethyl. Alright, now in terms of the location, if I start here, I get my first branches at 2. But if I start here, I get my first 1, 2, 3, my first branches at 3. So I'm going to have to start here. 1, 2, 3, 4, 5, 6. That's how I'd number this. So what I would have to put here is 2, 2, right, because I have 2 methyls at the second carbon. Comma 4, 4 tetramethyl hexane. All right, it's kind of bleeding into the next one, but that would be the whole name. 2, 2, 4, 4 dash tetramethyl hexane. All right, finding the longest chain here would be 1, 2, 3, 4, 5, 6. And at this point, it wouldn't matter if we went this way numbering 5 and 6 or this way. So either way. And I'm betting based off the numbering, I'm actually going to start numbering here. So I can get my first branch point at 3. Because if I started here, 1, 2, 3, 4, right? So I do have to, I was right. I got to start down here at 1. So I have, what was that, 3, 4, 5, 6. So I have another hexane, 4, 5, 6. And so this is yet again another 2-carbon chain. So that's an ethyl chain. So I would name this 3 ethyl hexane. Alright, so hopefully that does a good enough job preparing you for really getting into naming these structures. Alright, next it wants us to give Newman projections for each of these structures, and it wants an eclipsed one and a staggered for each. So these are kind of separated. So it wants an eclipsed one looking down the C2, C3, and a staggered one looking down the C2, C3. So if you recall the Newman projections, right, it's where you have the dot and the circle, and then the dot will have 3 arms coming off of it, and the circle will have 3 arms coming off of it. All right, and so that means you're kind of looking like down this bond. So the dot would be the C2, and the circle would be the C3. Okay, so this bond is more or less invisible to us in the Newman projection. So we really need to look and see what are the 3 things coming off of C2 besides this bond. Well, we've got a methyl group, so I'm going to put that. So on C2 we have a methyl, CH3, and then we have a CH2OH, so I'm just going to put it over here. No, I'm going to put it up top, CH2OH. And then the third thing is an invisible thing, right? We have a hydrogen that's there, so I need to put a hydrogen coming off right there. I'm just drawing a practice one, and technically it is staggered already. All right. And then looking at the C3, remember this bond is invisible, so the only one that's shown of the 3 that we're worried about is the one with the methyl. So I'm going to put CH3 here, methyl there. And so the other two invisible things are hydrogens. So I got a hydrogen and a hydrogen. Now, technically here I wrote a perfectly beautiful staggered one, all right? But remember, you can rotate, like you could pick the front, the C2 carbon, and just rotate stuff counterclockwise. So just to give you kind of another option for a staggered one, if, say, I moved all of these like so, so the CH2OH would now be down here, right? CH2OH down there. That would mean the methyl would move to over there, so CH3, and the hydrogen will move up there. So I'm actually giving you two different staggered ones. And then it's always best to only rotate either just the front one or just the back one. So since I rotated the front one, I'm going to leave this back one exactly where it is. So the three arms that come off here to make it staggered, I'm going to put CH3 there, and then H and H, H, H. So that would be a staggered Newman projection for that molecule. All right, now to do an eclipsed, what we'd have to do is like this bond and say that bond would have to be right on top of each other. So what we would have to see, I'm going to keep the hydrogens and the methyl on the back where they are. Okay. Now, for this, to do it eclipsed, I'd have to have it to where it's like almost right on top of it, like so. So what I would do is I would just move this CH2OH in front of the hydrogen here, CH2OH, and then that would mean that this methyl would move in the same direction in front of that methyl. Okay, and then this, that methyl moves there, so then this hydrogen moves in front of that hydrogen. Okay, so specifically what we have here are two methyls are eclipsed, these two hydrogens are eclipsed, and this hydrogen and this CH2OH are eclipsed. Okay, and then one other kind of interesting thing to talk about would be this interaction right here. These two methyls are 60 degrees apart from each other, so this is called gauche. Okay, that's a very special interaction. And then other things you could look at is if you looked at this methyl and that CH2OH, those two are actually what you call anti from one another. They're 180 degrees away. All right, they're as far apart from each other as they can get. So we call that anti. All right, but anyway. Now looking at our next one here, we have our C2, C3. So this would be my dot, that would be my circle. So I'm just going to start with the staggered one because it's always the easiest one to draw. So on my staggered one in the front, I'm going to draw my three arms. Remember, this bond right here is invisible to us in the Newman projection. We can't see it. So I've got two of the three arms are already shown. I have a methyl and a bromine. So I'm going to put the methyl up here and the bromine down there. And so the third invisible thing is the hydrogen. So that's what I'm going to put there. Now the circle, the carbon in the back, that's our C3. It has two things shown. It has a chlorine and a methyl. So I'm going to put the chlorine here and the methyl here. All right. And then with that, you have an invisible thing, a hydrogen that needs to go on. So that would go right here. And so for this has a couple of interesting things. This one has the chlorine and the methyl. They're gauche, right? So these two are gauche. Also, the bromine and the methyl here are gauche to one another. Okay. So they're 60 apart. But also, these two methyls are anti to one another. This chlorine and this bromine are anti to one another. So those are some other interesting vocabulary terms associated with Newman projections. All right, so in order to make it eclipsed, just pick one. So I think before what I did was I rotated the front carbon. So now just to give you extra practice, I rotate the back carbon. So that means I'm going to rotate the hydrogen down here. So let me keep the front one the way it is. So methyl, bromine, hydrogen. Okay, my bromine looks a little frumpy, but so what I'm going to do is I'm going to rotate everything 60 degrees this way, right? So clockwise. So that means now the hydrogen is there, eclipsed with the bromine. This methyl is here, eclipsed with the front hydrogen, and then this chlorine is here, eclipsed with this front methyl group. Okay, there's technically about three different eclipsed and three different staggered confirmations you could do. There are multiple correct ones, but I really just kind of wanted to show you one. Okay. But you could just keep rotating at 60 degrees, and you could get, technically there's always about technically six, but there's always 6 Newman projections you can draw. Some of them will look like repeats depending on the structure. These won't, but these you can get at least 6 distinct Newman projections. 3 different eclipsed ones and 3 different staggered ones. Alright, so anyway, so hopefully this helps. You kind of get a taste for Newman projections and how to show them. Alright, well, adios.